Hello students, welcome to the today's session of C programming. In that one we learn about the storage classes that are present in C programming. First of all, we'll understand what are these storage classes, right? Just to take one of the real time example, right? When we stay at our home, we are accessible at our home location. If you want to travel from one place to another place, and if you have booked a seat in a bus, right? During the duration of bus travel, your availability is in the bus, not at the home, right? Means the scope and visibility of you during the span of traveling is in the bus, not at the home. Similarly, when the variables are declared, they have their own lifespan and they have their own visibility, that is from which part of the program I can access. They are decided by the storage classes. So, storage classes will give us the information with respect to the variables and functions regarding what kind of memory space is allocated to them, whether they are available in the register or are they available in the RAM, how long they exist in the memory. Next one is which part of the C program can access those particular variables and functions. It also gives the information about whether the variable has any link to the external another file, or is it just internal to the place or the function where it is declared. It also gives us information what is the automatically allotted default value to the variable if it is not initialized in the program. So first of all, we'll start with the scope of the variable. The scope of the variable talks about the accessibility and the visibility of that particular variable at the different points of the program. Right? There are 4 scopes. They are block, function, program and file. Which one we'll see one by one. Right? As we all know, block of a code means the program statements which are included in the starting and ending flower braces. It can be a function, it can be a looping statement, whatever the statements we write within the starting and ending flower braces, we tell they belong to a particular block. If we write a variable creation in this particular block of the code, then its life will be within this particular span of or the area till the start of execution of this particular braces till I exit from this block. The life of the variable lies only within this particular area. Just take an example here. I have a main program. Within the main program, I am making a call to a function called as function 1. As soon as the function call is made, the control will be passed to the location where the program is written. Right? In the main function, I have called function 1, and my control is transferred to the location where the function 1 is being written. Then in the function 1, I am creating 2 variables, int a and I. These 2 variables are within the curly braces, right? They are within the curly braces, means they belong to the block of function 1. They are only accessible here. If I write a print statement here to print the value of a or I, it will not execute because the variables are local to the function 1 and they are not accessible in the main function. Similarly, let us take one more example. I have a main program. In that one, I am initializing the x to 10, right? After that, I have one more integer variable set to I, and I am printing the value of x. So as of now, x has the value 10, so it prints 10 here, right? The value of x outside the while loop is 10. When I come to the block of while, right? The block of while has a life between these 2 starting and ending flower braces or curly braces, right? So look here, what is happening in this while loop? I am checking, is the value of I less than 3. Until the value of I is less than 3, I will execute these 3 statements repeatedly. When it becomes false, I am coming out of this particular while. Okay, let us see what is the value of I here. As of now, I is equal to 0, right? As of now, I is equal to 0. So 0 less than 3 is true. Okay, so I enter the while loop block here, right? So in here again I have created a variable x which is equal to I now, right? So x value initially becomes 0. Look here, this x is local to the block of file. Its lifespan is within this one. So initially x is equal to I, means x is equal to 0. When I print the value of x inside the while loop, initially it prints me 0, right? I am incrementing the value of I, so I will be incremented to 1 here. I plus plus means I will be incremented to 1. So when I will be incremented to 1, what happens here? Is 1 less than 3? Yes, it is true. Means I will go to the while loop next iteration. Okay. So here x is equal to I. Present value of I is what now? It is 1. So x will be now replaced with value 1 here. So when I print the x value for the second iteration, it will print me 1 here. Previously it has printed 0. Now it will print 1 for me. Again I am incrementing the value of I. So 1 will become plus plus is equal to 2 now. Again the while loop continues. This time I am checking, is 2 less than 3? Yes, it is true. Again I will continue with the while loop. So again x is set to I. The present value of I is now 2. Present value of I is 2 now. So the value of x inside the while loop is now printed as 2. Again I will be incremented, right? So when the I is incremented at this time, the previous value of I was 2. Now when it increments, it becomes 3. Again I am checking for the while condition whether it is true or false. Is 3 less than 3? It is false, because 3 is not less than 3 but it is equal to 3. I am coming out of the while loop, right? So look here, when I have come out of the while loop, if I want to print the value of x, now the life of this x is over, which was holding the value 0, 1, 2, its life is over now. When I print the value of x outside the while loop, it takes the value as 10 and prints here, right? So because the scope, the visibility of this x is within the block while not outside this particular block. Next one is function scope, means the variable which are visible from the beginning till the end of a particular function, right? Their visibility is within a particular function only. Let us take the example of a go to label. Okay, so look here, I have written a main function and I have a move to the function scope. The function scope tells that the visibility of the variable is within a function, it's active and it is visible from the beginning till the end of a function, right? So let us take the example of a go to label. Let us look into this particular program. I have a main program. Within the main program I have a label called as loop, and I have written some statements, they are processing, right? As soon as the control comes to this particular statement, I am telling go to the label, right? So again I'll go back to this particular location. Again this code will be executed, right? This particular label, right, its life has started from the beginning of the function and it is available throughout the function, right? The label loop is visible from the beginning till the end of the main function. So it is called as function scope. Next one is the program scope. We said whenever the variables are declared within the function, right, we had taken one example of declaring the variables I and a within a function called as function 1. So its life was from the start till the end of that particular function 1. Okay, they are not accessible outside their territory, right? So the program scope, there are two things. One is a global variable. In that one, if I want to access a particular variable, not only in one function, but into another particular functions also, I will make it as a global. So its availability is throughout the program. Its availability is throughout the program, not restricted to a particular function. Okay, so its lifetime is as soon as the program begins, its life starts throughout the program's execution. Whether the function ends, function begins, doesn't matter. It is talking about, I am talking about a whole program here. From the beginning of the program till the end of the program, the life of the global variable exists. It is recommended that whenever we are declaring such global variables, it are better that we declare them outside all the functions, including the main. We should declare it above, that is outside the main also. Look here, I have a variable. My main program is here, but this variable is declared outside everything. Okay, so this makes a variable as global, means it is accessible in the function add, it is accessible in the function main. If I have written one more function called as print, it is accessible inside that one also. Means the global variable scope is within throughout the program. It is not restricted to a particular function. So x is equal to 10 has access to all the functions which are available in my program. Remember, if I have a local variable, look here, function add has begin here. I have a variable int x is equal to 0. It is present in this particular block here. So life of this x is within the add function, but its name clashes with the global variable. Whenever there is a clash between the local variable and the global variable, always the local variable overrides the content of the global variable. The value of the local variable has the upper hand within the function if its name is same as that of the global variable. Okay. Next we have file scope. Within the file scope, whenever a global variable is accessible until the end of the file, right, means it is not restricted to a particular function. This global variable is accessible until the end of the entire file. Then we call it as its life is for the file scope, right. Whenever we want to declare a variable whose life is to be set to a file scope, we use the keyword static here. Before declaring a variable, if I make it as a static, its accessibility is a file scope, right. A global static variable can be used anywhere from the file in which we declare it, right. Its accessibility is throughout the file. Remember, if I have two files, I cannot access the content of one file from the another file, but within the same file I can access anywhere this particular variable with the file scope. Next is the storage classes. There are mainly 4 storage classes. They are automatic, register, external and static. Whenever we are declaring the variable, we can mention to which storage class they belong to, what is their data type and what is the name of the variable. Right, let us see what are the meaning of these four storage classes. First one is auto storage class. Automatic storage class means whenever any variable is created, by default its storage class is set to auto. Right, if I am declaring a variable int x without using this keyword also, without using the keyword also, if I am just writing the variable as int x, automatically the storage class is auto only. Okay, so whenever a block begins within which you have created the variable, its life starts. When you are exiting out of that particular block, the life and the visibility of this particular variable vanishes. Then is the memory for this particular variable is automatically allocated when you enter into the block, and it's automatically deallocated when you are coming out of that particular block. As we learnt in a while loop, the life of the x has started when the while loop started and it ends when I am coming out of the while loop. Right? So automatically the memory will be allocated and freed as soon as it enters the block and exits out of the block. Similarly, the scope of this variable is only restricted within the block in which it is declared, right? And it is stored in the primary memory of the computer. It is stored in the primary memory of the computer. And remember, if you are not initializing this variable, it is not initialized to any particular value like 0 or -1. It will have some garbage value. Wherever the memory location is free, x is given that location. So any other program might have run, any other data will be present in that x, any garbage value will be present, right? So whatever the value will be present, that will be read. Automatically they are not initialized at the time of the declaration until user passes a value. So let us take a example here. We have function 1. Within a function 1, I have a variable a is equal to 10. Look here, the function 1 has a variable a, means this a has local to the function 1. Right? So if I print here, as of now the value available with me within this block is 10, so I print 10 here. Okay, so within this particular function 2, the value of a will be 20, so I will be printing 20. Okay, let us begin with the main function. Main program has begun here. In that one, I am initializing a variable a is equal to 30. Since auto is a default storage class, automatically using of the auto keyword is redundant, no need of using it. By default it will make the variables auto only, so no need of using the keyword auto there. If you just write int a, is making it a auto variable, right? So int a is equal to 30. Now this 30 is local to the function main. Let us see, as soon as a variable is declared and initialized, I am calling the function 1. So when the function 1 is called, I am moving to the location of function 1, wherein again a variable a is created and it is local to the function 1. So when I print the value of a within function 1, it prints 10. When it prints 10, I am coming out of the block, so control will be passed to the next statement within the main. So next statement within the main is call to the function 2. So when I called the function 2, the control will be passed to the location where the function 2 is written. So within the function 2, I am initializing a variable a once it is declared, I am initializing it with the value 20. So within the function 2, it prints the value 20 and comes out of this one, and the next statement to be printed in the main, it goes, right. So here I am printing the auto integer local to the main a, and it is printing the value of a here, right. So the output would be, so when I call function 1, 10 will be printed. When I call function 2, 20 will be printed, and the life of a equal to 10 is over when I come out of this block. Life of a is equal to 20 is over when I come out of this function 2. When I come back to the main, who is alive? A with the value 3 is alive now. So I will print the value 30 here. The next one is register storage class, right. Here, whenever the variables are created, they will be allocated the space whichever is free, right. But here you are insisting the compiler to give the location to store a variable in the register only, right. You are requesting the compiler to allocate the memory within a register only, right. So the request can be given to the compiler telling that I want the storage in the register because I may want to do some quick calculation. Always remember, the registers have the direct access, right. They don't have any memory allocation or memory address is available to them, right. Directly I can access the content of registers, so the calculation will be faster. Only thing is, the variables when they are stored in the register, the maximum size depends upon with which system you are working, right, because the register size varies with the system. So since the variables are stored in the register, you should make sure that the maximum size of the variable should be equal to the register size there. So it varies with the system. The syntax to declare a variable with the register storage class is, you should use the keyword register followed by data type followed by the name of the variable. So whenever you are requesting the compiler to allocate the register storage, now this request can be denied if the register is not available during that particular time. The request can be denied by the compiler. Only the advantage is what? Quick access is possible, and the drawback is that you are unable to access the memory location associated with the variable. And one more thing, if the compiler, if the programmer just asking, it is just requesting to give the register to store the value of the variable, it depends upon the compiler whether it accepts the request or rejects it. If it rejects that it is not able to allocate the register to store the variable, automatically those variables are treated as again the auto storage variables. So when again it comes to the auto variables, as I said, they will, as soon as they enter a block, their life starts. When they come out of that particular block, at the moment you are exiting from the block, your existence will no longer be existing there, right. Now registers, I may request to store the information in the register. If it is request is rejected, automatically they are converted into the auto variables. As we know, the automatic variables will have their life within a particular block. Entry into the block, their life starts. When you exit out of the block, their accessibility is stopped there. Next one is external storage, right. The external storage classes are available, that will be continued in the next session.